Have you ever wondered why your car's connection sometimes just drops out in some locations? Or why your vehicle struggles to receive critical updates, like warnings about traffic jams or accidents, until it's almost too late? You know, many of us have also experienced when the software update isn't really finished in the morning, leading to some of the car's functions being turned off. All of these things can be very annoying or even critical for safety. So why does this happen? Often the bottleneck is actually the car design itself. You see, a car is basically a big metal shield that blocks signals. And modern designs with glass or carbon fiber roofs make the design of the wireless system of the car even harder. And the car's wireless system is the core of the car's communication with the outside world. And the function of the antennas in these systems is extremely important. So for modern vehicles, and this is just as true for autonomous defense vehicles as it is for the car in your driveway, where you place the antenna is not just a detail today. It can actually determine if the system works or fails. Here's the thing. Real communication quality isn't achieved by just checking the car once at the very end of the development phase. It is determined by continuous testing throughout the entire development process. That is the only way to catch issues early and optimize them. Usually, that kind of frequent testing is impossible in a traditional way. It takes too much time, and these large facilities needed are way too expensive. But RanLOS solutions completely change that dynamic. It allows engineers to run tests with our easy-to-deploy system right in their own facility, or in a simple test tent setup. And this can be done day in and day out, whenever needed. To give you a real example of why this matters, we tested different design cases where we simply moved the antenna from the back of the roof to the front. This simple change caused the signal strength to drop drastically, which in turn greatly affects the distances at which wireless communication can be used. The communication distance can actually drop tens of kilometers. That's a huge loss of performance, just from a minor placement change. So, by enabling engineers to test constantly, we ensure that whether it's a self-driving car or a critical field vehicle, the connection stays strong when it matters most. You can read more about the application for the automotive industry in our application note called Unlocking the Optimal Antenna Placement for Cars. You can find it on the RanLOS website. Until next time, keep your signal strong out there. RanLOS